In this video, we're going to be reviewing the process of completing the square. And this is a skill that's going to be very helpful when we are working through our conics unit. So when we are completing the square, what we're basically going to do is take two terms of a quadratic expression, and we're going to find the third term that would make it a perfect trinomial square, which means that it factors as the same binomial twice. And then it becomes a perfect trinomial square. So it's a super simple process as long as you can remember what you need to do to complete the square. We start by looking at your middle term. In this case right here, I have negative 10. To complete the square, I'm going to take half of that value. So if I take half of 10, I'm going to get 5. And now, to complete the square, what I'm going to do is once I have half of that value, I square that amount. So 5 squared would be 25. And that's going to be the value that would complete the square. So if I wanted to know what value would complete the square, I would say n would have to be 25. So then my quadratic would become x squared minus 10x. It's always going to be plus the value at the end. And then the reason this becomes a perfect trinomial square is because now if I factor this, this would become x minus 5 times x minus 5. So the negative 5 times negative 5 would make that positive 25. And then the inner and outer together would combine to make that negative 10x. It's considered a perfect trinomial square because now I can write that as a binomial x minus 5 squared. So anytime we need to complete the square, that's the process. You find your b value in front of your, x in this case, take half of that value, and then you square it. And that's how we complete the square. As you're working through the puzzle worksheet, they're going to ask you a couple different ways of completing the square. So one of them is just purely figuring out the missing value. But we can also use completing the square to help us solve some quadratic equations. Now, normally we would try to think about how could we factor this, and yes, this would be factorable and we could easily do this without completing the square. But I'm going to show you how we could solve this using the completing the square method. And this works out great when the problems are not perfectly factorable. So in this case right here, when we want to solve by completing the square, what we do is, some people call it like boot and scoot. We're going to basically make it so that it looks like this problem right here. We're going to get the x squared term we're going to keep, the x term we're going to keep, but we're going to boot the constant to the other side. So if you have a constant already here, we're going to move whatever constant to the other side. You might not need to do this step, but for this one we need to. So obviously if I want to move the constant to the other side, I would subtract the 3 from both sides. Now what I'm going to actually do is leave space there so I can complete the square, because my goal is going to be to turn the left side of this equation into an expression like this right here, that binomial squared. So I move that constant to the other side, so that's going to now give me x squared minus 4x, I'm going to leave some space to complete that square, equals negative 3. And now what I'm going to do is I'm going to complete that square. So again, I take half of this middle number, so half of 4 would be 2, and then 2 squared would be 4. So to complete the square, I would put plus 4 here. Now, because this is an equation, if I put 4 on one side of my equal sign, I also have to balance out my equation. So I'm going to add that same amount to the other side. So in this case, I'm going to add 4. And now what I've done is, again, created this perfect square, trinomial, and I'm going to factor this. So this is going to become x minus 2 quantity squared equals negative 3 plus 4 is 1. And then I'm going to solve this problem for x. So I'm going to bring this up here. So if I want to solve this problem for x, the first thing I would do is take the square root of both sides. But we have to remember when we're solving using square roots that not only do I take the square root, but I have to do that positive and negative square root of both sides. So I'm going to take the square root of this and the positive and negative square root of that. And because that square root of 1 is a perfect square and the square root of 1 is 1, I would get x minus 2 equals plus or minus 1. And then now to get x by itself, I just would add 2 to both sides. And I would get x is equal to 2 plus or minus 1. And so I'm going to get my two solutions that I could have gotten if I could have just factored this from the start. X is going to equal 2 plus 1 or 3, or x is going to equal 2 minus 1 or just 1. And those would be my two solutions if I'm solving by completing the square. And again, I could have just gone back here and factored numbers that multiply to make positive 3, but add to give me negative 4. I could have just done x minus 3 times x minus 1 equals 0. And notice I'm getting the same two solutions. X would equal positive 3 or x would equal positive 1. So this was a silly example because it worked out already. So to complete the steps there, I move the constant to the other side, complete the square on the left side, and balance the equation. And then we basically finish up by solving. Easy. All right, so that one was a silly example because again, we could have just factored. So we're gonna look at one more example where this one would not factor. Even if I brought the 5 over to the other side, there's no way I could find numbers to multiply to make a negative 5 but add to give me 8. So we're going to solve by completing the square. Now my first step would be to move the constant to the other side. You're going to notice it's already there, so I don't have to worry about step 1. So what I am going to do is complete the square and balance the equation. So I'm going to go x squared plus 8x, leave some space, equals 5. And then I'm going to complete my square. So again, find that middle term there, that 8x, take half of that coefficient, so half of 8 is 4, square it, that would give me positive 16. If I add 16 to one side, I'm going to add 16 to the other. Once I complete the square and balance the equation, I'm going to solve it. So in order to solve it, I start by factoring this left side. So again, it's a perfect square. So 4 times 4 makes 16, and 4 plus 4 gives me that 8. So this would factor as that quantity of x plus 4 squared, and then 5 plus 16 is 21. And then to start solving for x, I would take the square root of both sides. And on this right side with the constant, I'll make sure I take my positive and negative square root. So that'll give me x plus 4 equals positive or negative square root of 21. If I could simplify this radical, I could. So kind of like here, the square root of 1 was 1. If this was like the square root of 12, I would break that down as 2 radical 3. But 21 breaks down only as 7 times 3, so that can't be simplified anymore. So I'm just going to subtract 4 from both sides to get x by itself. And I'm going to write negative 4 plus or minus radical 21. Now, most of the time we would leave that as our answer, but I think on the puzzle worksheet they do ask you to round it out. So again, you just have to remember you're really getting two solutions, one of them being negative 4 plus radical 21, and you can just go on your calculator and figure that out and round it. So that would be about 0.583 using my calculator. And rounding it to the nearest thousandth. And then my other solution would be the negative 4 minus that radical 21. So again, if I wanted to figure that out, I could just type that into my calculator, negative 4 minus radical 21, and I get negative 8.583 that time. These are my exact values when I keep it in the radical format, and these are my approximations when I round them to the nearest, in this case, thousandth. So most of the puzzle worksheet is going to have you solve, and some of them will already be written in this format here. So you're going to have to boot the number to the other side and then complete the square. Some of them might be already set up for you in this format where you're just ready to jump in. And then there are a couple random problems on the puzzle worksheet that I wanted to make sure you understood how to do. And they bring you back to the area model for polynomials, and you probably haven't worked with the area model since Algebra 1. But really what they're going to do is draw you a bunch of algebra tiles. And they're going to tell you that the overall area of that rectangle is 42 centimeters squared. So when I look at my algebra tile, what I can see here is that I have this big block that's x squared. If I do the area, x times x. Each of these rectangles are a width of 1 and a height of x. So 1 times x would give me x and x. And then same thing here, a height of 1, a width of x, 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 x. And then each of these little squares are 1 by 1s, so each of these would have an area of 1 times 1 or 1. So in this area model, what I have for this big gigantic rectangle is x squared plus 1, 2, 3, 4, 5x plus 1, 2, 3, 4, 5, 6. That's the area of that shape broken up into those little tiny pieces, and they're telling me that the area is 42. There we go. So now, if I wanted to find the value of x, I would just go through the process of completing the square. So again, to complete the square, I'm going to boot the number to the other side. So I would subtract 6 from both sides. I'm going to leave space to complete the square when I do that, and then 42 minus 6 is 36. Then to complete the square, I take half of that value right there. So half of 5 is 2.5, and when I square it, that gives me 6.25. And now that I have it, I can go ahead and complete the square. So again, half of that was 2.5. So this is going to factor as x plus 2.5, quantity squared. And then 36 plus 6.25 is 42.25. And then to solve it, I'm going to go through all my steps. So again, take the square root, plus or minus. Let's see, is that a perfect square? That is a perfect square. So the square root of 42.25 is 6.5. And then if I subtract the 2.5 to get the x by itself, I would get x is equal to negative 2.5 plus or minus 6.5. Now, technically, we get two solutions to this problem, right? Technically, we say, all right, x is negative 2.5 minus 6.5, which would be negative 9. Or we would say x is equal to negative 2.5 plus 6.5, and that would equal 4. If this didn't represent an area model, we would keep both those solutions. But since this represents an area model and x is representing a side length, we can't keep the negative. So we would say that for this problem, x would have to equal 4. All right, so there are a couple random area models on your puzzle worksheet as well. And it's just good to review how algebra tiles work because you haven't really seen those since probably Algebra 1. That's been a while. And then it goes through and just gave us another example on how to solve by completing the square. All right, so good luck completing your puzzle worksheet. And if you have any questions, let me know.